McEuen. He is a neuroscientist at Penn.
Thanks, Brad. Okay, so this is a story about every second of every one of your lives, from the day you're born until the day that you die. Not to build it up. So my story begins at the summer of 2001 at MIT, where I was sitting outside my lab in my junior year, and a friend of mine came up to me and asked me for help solving a problem that he'd been having. Now, we were both at MIT training to become neuroscientists, and you may wonder why, but the answer is, fortunately, on the next slide. Let's wait for it. So I think the quote at the bottom, which is from the editor of Wired magazine, gives a good indication as to why we were doing this. And so my work at the time was taking these sort of smallest functional units of your brain, these little neurons shown at the bottom, and investigating how they talk to each other, which actually pans out into kind of an electric series of graphs shown on the top, translating that into something useful. The idea is you can take these biological singular units, map them, understand them, build them into really complicated models, which could show you a lot about how the brain works and how we understand things, and also how dysfunction can occur in the brain. Because there's nothing that you experience or feel that isn't dominated by the activity of these little biological units. So we feel happy or sad or curious or aroused. It's due in large part to the function of these simple little molecules that run back and forth between cells all the time. They can be something as simple as sodium, one of the periodic table elements, but something that simple can be profound enough to put you into a seizure or a coma, or make you just feel really good. And I think that raises an interesting point about the drugs we make and put into our bodies to get into our brains, which when you do so, kind of get into all the other tissues of your body where they can cause lots of harmful side effects. And what small fraction gets into the brain, only a small fraction of that actually gets to where it should be to do what it's designed to do. So my friend and I came up with kind of a new way of solving this problem, where we take those drugs that already existed and put them inside these little tiny molecular envelopes, so that when it would go all throughout the brain, it wouldn't actually do anything until we wanted it to. The tiny fraction that would get up into the brain, as opposed to the rest of the body, would get triggered remotely to turn on, and that way you'd get all of the benefits of the drug without any of the nasty side effects. So this got the attention of some very dashing professors at MIT, which got us access to a little bit of money and a little bit of space in one of the campus buildings. But by the time you spend money for research animals, oscilloscopes, and amplifiers and microscopes, you'll be surprised to find that after about 2 months, you're completely broke and you have all this stuff to do. We had a lot of proof of concept issues, as we call them, with this project. We had to prove that we could make an envelope out of molecules that would encapsulate an inactivated drug, that we could put that into the body, get it up to the brain, and then remotely trigger it, like I said again, right where we want it, right when we want it. And a lot of that had never been done before. Excuse me. So when you come into the situation where you have all your stuff and no money to use it, what you usually do is write a bunch of grants. And so that's what that process is essentially like. You have no money, you have no sleep, but you have a computer and you can type to no end. To institutes like this, both public and private, which put millions of dollars into projects like ours every year. Oh, have we frozen? The guy's not banging his head. Okay, so anyway, the one team, the one group that saw a lot of promise in what we did is called the Defense Advanced Research Projects Agency, or DARPA. They were formed in the 50s by the Department of Defense to basically bridge the gap between the technology of the future and the ideas of today, when there might be 20 years in between. They brought us the internet, they brought us satellites, they brought us unmanned cars and solar-powered gliders, some of which you may appreciate, some of which you may not. They gave us some money, which was fantastic, because we could move into a bigger, cooler building, we could get equipment, we could do those proof of concept experiments that we need to actually launch a product or convince any hospital to go with us. It never really occurred to us to matter that we were getting funded by the Department of Defense. Which brings me to the ivory tower of science. A lot of times scientists like me do their work in their labs trying to cure something about the human condition and never think that, or not with any severity, that somebody might take that idea and use it for slightly less altruistic motives, which in our case kind of happened. So some of the technology that we were working with at the time, which we called a tetrode array, allows you to actually read the minds of, in this case, a rat, to see where they go, to reconstruct the little electrical activity of the brain when it makes a left turn or a right turn, and reconstruct where it is, where it goes. It's actually being used by the military to sort of map alien terrain. And it connects a lot with what we were doing, because you could potentially inject one of these molecular envelopes with a drug in it into someone, And whenever you want it, not when they want it, turn it on wherever you wanted to in the brain, not where they wanted to in the brain. And so the implications of this are false memories, erasing memories, creating stress, creating fear. And again, it sort of underscores that all these little innocent molecules have those powers. And if you put those in a little envelope and send them to a particular part of the brain, based on what we know now in neuroscience, you can actually elicit a lot of those dramatic effects in somebody, kind of like the Manchurian Candidate. So this isn't the first time that science has been used to this end. There's some Freedom of Information Act releases from the 70s where the CIA tried to condition people like Pavlov conditioned dogs to respond to a bell or to something else. And on the right here, these are actually LSD experiments where an artist was asked to do a self-portrait of himself while tripping, again, by the Department of Defense. So for better or worse, we didn't work for DARPA for more than a year or so. For whatever reason. But since then, their research has gotten a little bit crazy. They've made remote control cockroaches, which, again, kind of go to this attitude of mapping out foreign terrains. They make super suits and things like that. And it kind of makes me think again of that scientist in his lab trying to solve some problem with the human condition and being funded by research agencies, private or public, government funded or personally funded, that may have very different motives. And while it may improve the life expectancy of people in many parts of the world dramatically over our modern history, it doesn't always have such great endpoints. For example, as one could imagine, you can take a scientist and put him in a room to try and solve a problem with a bunch of people, and some of those people are scientists and some aren't. And years later, down the road, you get a new drug or a vaccine or the satellite or a spaceship or the internet and computers. At the same time, the same scientist with the same great ideas and the same altruistic goals can be put in the room with a slightly different set of people, and it can lead to slightly more catastrophic results, as has occurred. But this has been going on as long as we've recorded history, and I don't think that, in short, you can separate the drugs of tomorrow that help us live longer and cure diseases from the devices that help us kill each other more effectively than ever before. So without those remote control cockroaches, you may not have the artificial sweetener in your coffee today.